Hi, this is Andrea Hendricks, and I want to talk to you about the second part of rational functions, that is, the function of the form 1 over x squared. So let's begin by examining the key components of this graph and see if we can get a basic shape. So if we want to find the x-intercept of 1 over x squared, recall we would have to set that function equal to 0. So we would get 1 over x squared is equal to 0, and then we would cross multiply, which would give us that really 0 is equal to 1, which of course doesn't make sense. So that tells us that there is no x-intercept for this particular graph. Now for the y-intercept, we would have to plug in 0 for y to get y is equal to, I'm sorry, I said 0 for y, 0 for x, to get y is equal to 1 over 0 squared, but that would just be 1 over 0, which is not defined. Do you remember that basic fact that division by 0 is undefined? So this tells us that we have no y-intercept. So again, we see a graph that's going to have those same characteristics that 1 over x did. We need to look at some key points that are on the graph. So let's look at a table, and let's say we plug in the values of 1, 2, 3, and so on. If we plug in 1 for x, we would get 1 over 1 squared, which is just 1 over 1, or 1. If we plug in 2, we would get 1 over 2 squared, which is 1 over 4. If we plug in 3, we would get 1 over 3 squared, or 1 over 9. So notice that this has the same properties. That is, as we're increasing in the x values, our y values are getting smaller and smaller and smaller. And so we can say that as x is going to infinity, y is going to 0. Now, of course, I don't have infinity represented in the sense that I'm not getting very large, but you can imagine if I put in 100, right, that would be 1 over 10,000. Or if we put in 1 million, we would have a huge number in the denominator, which makes that fraction very, very small. What if we have values that are negative? So if we put in negative 1, negative 2, and negative 3, well, 1 over negative 1 squared is 1 over 1, or 1. 1 over negative 2 squared is 1 over 4. 1 over negative 3 squared is 1 over 9. So do you notice something interesting here? Opposite values of x have the same or equal y values. Do you remember this is called an even function? Even functions have the property that they're symmetric with respect to the y-axis. So we'll see that here. So this same property results, that is, as we say x goes to negative infinity, y is going to 0. So we have 1, 1, 2, 1 fourth, 3, 1 ninth. Again, I can't even graph those. Negative 1, 1, negative 2, 1 fourth, negative 3, 1 ninth. So you probably can see what's going to happen between the 0 and the 1 and the negative 1 and 0, but let's just do that. Let's say if I want to plug in values that are really small, let's plug in 0.1. So I'd get 1 over 0.1 squared, which is really 1 over 0.01, which is going to be 1 divided by 100th, or 100. Because of the even properties, if I plug in negative 0.1, I'm going to get the same result. So at 0.1, my graph is way off the screen. It's at 100. I'm just going to do a dot up here to represent that. So my graph is going to look like this. Again, kind of hard for me to graph it without crossing that. I'll show you a better picture in just a minute from the calculator. But it really does not cross that y-axis at all. Sorry that my graphing tablet won't let me show you that really well. But what we can say here is that as x is going to 0 from the right, y is approaching infinity, right? And as x is going to 0 from the left, y is also approaching infinity. Okay? Now, for the better picture of that, if I looked at the graph of y is equal to 1 over x squared on the graphing calculator, I would see this particular picture. So my vertical asymptote is still this line x equals 0, and remember why we know that's true, because the function is undefined there. We also know that as x is approaching 0 from the left and the right, y is going to infinity. My horizontal asymptote is a horizontal line, y is equal to 0, and that's because as x is approaching plus or minus infinity, y is approaching 0. Okay, so even though they're not drawn in my graph, I really envision this dotted line through there. Okay. Now what about the domain and the range? Domain is everything but where it's undefined, which is at 0. So negative infinity to 0, union 0 to infinity. My range, now be careful here, it's not the same as 1 over x, right, because I don't have any output in the negative direction. They're all positive. So my bottommost value is 0, but not really 0. So I use parentheses there to infinity. So notice these key components. So whenever I go to graphing some shiftings of this, so if I wanted to graph y is equal to 1 over x squared minus 4, what is that going to look like? I need to think about where's it undefined, what's happening to my asymptotes. So my vertical asymptote at x equals 0 is still there. What about my horizontal asymptote? Yeah, my horizontal asymptote was at 0, but now it's got to shift down 4 units. So now my horizontal asymptote is at y is equal to negative 4. I still have my vertical asymptote. Use your imagination if this was a vertical line. Should have imported a graph there. But what I need to know are some key points on the graph. And remember that 1, 1 is a key point. So if I shift that down, that becomes 1, negative 3. And likewise, I have a negative 1, negative 3 here. So my graph would look like this. Okay. Again, approaching that asymptote, really not crossing that at all. What about the domain and the range and the end behavior we can talk about? Domain is negative infinity to 0, right? Union 0 to infinity. My range would be what? Yeah, now we start at negative 4 to infinity. Okay? Now, here I'm going to show you how we can look at this on this grapher. So what was that function? 1 over x squared, then minus 4. Okay, and there it is, right? So I see my asymptote at this negative 4. Oops. And my vertical asymptote as well. Okay. So 1 over x squared is just another one of those basic functions that you need to add to your set, and then you need to be able to transform it in the ways we've talked about. So if you watch the homework video and the calculator video, I'll show you more examples of the transformations that you'll need to do. Okay? Thank you, and have a great day. Bye-bye.